The second property, the periodic property to be discussed here is the ionic size. Ionic size means the size of the ions. We know we can have two types of ions. If metal A, the metal atom A, or you can take, like you can assume any atom A, if it loses electron, it becomes positively charged ion, which is called cation, and if it accepts electrons, it becomes a negatively charged ion, which is called anion. Now, in this case, the number of electrons are less than the usual atom. So that's why nuclear pull is higher. Whereas in case the number of electrons are more than the usual one, the usual non-neutral atom. So the pull on these electrons, the nuclear pull is less. So what we find is, moreover, they have more inter-electronic repulsions, due to which the electron goes away from each other. That's why what we find is, what is the trend in the sizes? The increasing order of their sizes, that the cation will be the smallest one, followed by neutral atom, and the largest will be your anion. So this is the usual trend. Now we have to study how this ionic size varies in the periodic table. Remember, ionic size, like atomic size, is also expressed in Armstrong's unit or in nanometer. And the most important thing is that the trends shown by ionic size are very similar to atomic size. We don't find any change in this. It's exactly the same. What trends? Along the period, the ionic size also decreases as the atomic size increases. And along the group, what we find is, as the atomic size increases, ionic size also increases. So the trends are same. So in a period, it's very obvious, ionic size decreases. Why? Because atomic size decreases. Similarly, in a group, ionic size increases because atomic size increases. So the trends are very much usual. What is more important to note in this case is, the special type of species which are called isoelectronic species. What are isoelectronic species? The species, maybe cations or the anions, which contain same number of electrons. So what is generally we find is that we are asked to find out what is the trend among the isoelectronic species is. Let me give you the example, like N3 minus, O2 minus, F minus, the neon, Na plus, Mg2 plus, all of these are your isoelectronic species. You know, nitrogen usually contains 7 electrons. -3 charge makes it has 10 electrons. Oxygen contains 8, 2 minus means it is also having 10 electrons. Fluorine contains 9 electrons, -1 means it is also having 10 electrons. Neon usually contains 10 electrons, it's in an atomic state. Sodium contains 11 but it loses 1, so it's having 10 electrons. Magnesium contains 12 electrons, loses 2, so it is again having 10 electrons. So all of these are having 10 electrons. So all of these are isoelectronic species. Now in isoelectronic species, how we can arrange these species in the increasing or decreasing order of the atomic size? Remember, the smallest will be your or what we can write is among electronic species. The smallest will be your cations, then your usual atoms, and then ions. What I can tell you is, the most important is that the cation size is directly proportional to, inversely proportional to positive charge. Larger is the positive charge, smaller is the cation size. So out of sodium and magnesium, magnesium is smaller than sodium. What we find in case of anionic size, they are directly proportional to the negative charge on the ion. Larger is the negative charge, larger is the size, because more the number of electrons are there, more interelectronic repulsions, lesser nuclear pole, they move away from each other more with the, to larger distance, to more away from each other. That's why the larger is the size. So that's why on the basis of these basic trends, we can arrange these 6 species like this. The smallest out of these is Mg2+, followed by your sodium, then we have usual neutral atom neon, then we have fluoride, then we have oxide, and then we have your nitride. So this is your usual trend of these 6 species.